This is section 5.5, solving logarithmic equations, type 2. So we're going to be looking at and reviewing again what type 1 logarithms were. So we had this property, y equals log base a of x, which is equivalent to x equals a to the y. So for logarithmic type 1, you can see that we were putting it in an exponential position, and we're going to do a similar way of doing that in type 2. So the type 2 property says that you have log base a of m is equal to log base a of n is equal m to the n, which actually is very similar to exponential type 2, if not the same. The only difference is in exponential, we brought down the exponent to the front of the logarithm, versus for logarithmic, what's going to happen is the value in front of the logarithm is going to want to move into the exponential position. So it's just the opposite of the exponential. So let's do a few examples of this. So the first thing I do is look for, okay, is this exponential or is this logarithmic? Well, I can already tell two things about this problem that tell me if it's a type 2, and it tells me if it's logarithmic. So I can see that it's type 2 because I have a logarithm on both sides of the equal sign. If we had a type 1, we'd only have a value, so it would be like 36, and both logarithms would be on the left-hand side. So I know this is a type 2. And also, I have a value in front of the logarithm, so I know this is type 2 logarithmic because I have a value in front of a logarithm. If it was exponential, the 2 would already be up by the x squared, or by the x, so we want to move down to the front. So that's what we're going to evaluate first, is we're going to move the 2 up to next to the x. Now, in front of the other logarithm, we don't have anything in front, so I don't have to worry about that. So it's going to be log 4 of x squared equals log 4 of 36. Now the next thing we have to do is I have to look at my property again, and if I have m equal to n, this means that if I have two logarithms that are the same, you see here how they disappeared? So we had log a on both of them, and now they've disappeared in that step. That means that if they have the same value for the base, that means they get crossed out. They go away. So then we're left with x squared equals 36. But what do we do if we have x squared? Well, what happens is we have to take the square root of both sides. So let's take the square root. So the square root of 36 is 6. And remember, when you take the square root of x, what happens is the square goes away and you're just left with the value of x. So this is our answer for this. But is it right? No, because you have to have, anytime you take the square root, you have to take the plus or minus of that value. So technically, it's plus or minus 6. And then what we do is we can check to see if our solution is correct. And how you would do that is you put that value, plus and minus 6, into the x position in your equation and solve to see if it's equal on both sides. So let's do the same setup again. So try the second one. So let's see. Okay, so do the same exact thing. I move my 4 up to the exponential position. The logarithms are the same. You cross them out. You have x to the 4th. Well, x to the 4th, if I was to evaluate, that means I'm going to have the 4 square root of 16. So in my calculator, if you want to do the 4 square root of 16, I would find this button, and I would put the 4 here. So in my calculator, 4 square root of 16 gives me the value of 2, a plus or minus 2. Remember, if you take a square root, or not a square root, but anytime you take a root of something, you have to have a plus or minus. Okay, so let's do a few that are a little bit more challenging. Okay, so let's try this one. Log base 3 of x plus 4 minus log base 3 x minus 2 equals log base 3 of 9. Okay. Well, this one's already 10 times easier because we don't have any exponent, so we don't have to worry about that. Since there's no value in front of our logarithms, that means, so here, here, and here, that means I don't have to worry about trying to bring up the exponent. But we have a minus here, so that means I have to incorporate my 3 rules that we learned in 5.1, which are the product rule, the QR rule, and the power rule. Well, we don't have to worry about the power rule, so that's not a problem anymore. But we have a minus here, so which rule would that be? Well, the product rule says that if I have addition, I have multiplication. And the QR rule says that if I have subtraction, I have division. So I have subtraction here, so it's definitely my QR rule. So that means I'm going to divide. And since I have the same logarithm, what's going to happen is they're going to be under the same logarithm together. This is my A and this is my B. So the A is going to be on top and the B is going to be on the bottom in the same order. But now we have to use our new rule, which is the 1-to-1 property. Which type 2, which states if they have the same logarithm on both sides, that means they can disappear, they go away. And then we're left with x plus 4 over x minus 2 equals 9. But then what do I do? Well, this is going back to when we were solving problems with the LCD. So I use my LCD here, and I multiply it to both sides. And when I do that on the left-hand side, it gets taken away. And now we just evaluate like a normal algebraic equation. So how do I simplify the right-hand side? The left-hand side is simplified. What I do is I distribute. So we get 9x minus 18 equals x plus 4. But now I want to combine like terms. So let's see. Let's move the x to the right-hand side and let's move the 18 to the left. So that will be 4 plus 18 equals 9x minus x. So 9 minus 1 is going to give me 8x. And then let's see, 18 plus 4 is 22. Then I want to get the x by itself, so I divide the 8 out so that I get x equals 22 over 8. But are we done? What can we do further? So let's see. Well, what number goes into both of these? Well, I see that 2 goes into both of them. So that means it's going to be 11 over 2. So this would be 11 over 4. And that would be our solution. So x equals 11 over 4. Now we can actually evaluate our domain. So our domain is going to come from the x plus 4 and the x minus 2. So how do I write that? I write that as x plus 4 is greater than 0 and x minus 2 is greater than 0. And if I was to write this again, it'd be x is greater than minus 4, and x is greater than plus 2. So let's see what our domain is. Our domain, so if I divide 11 over 4, 11 divided by 4, gives me 2, so if I were to evaluate that, that's 2.75. So which one actually work? So it's gonna have to be that x is greater than 2. So that means our domain is gonna be x is greater than 2. So this will be our domain, because it's closer to the 2 than it is to the negative 4. So this is our domain. And I could also write this as a domain is 2 to infinity. Okay, so let's do one more like this, and we'll walk through, and I'm going to have you do this one on your own. And then we'll come back and see if we can do it together. So let's try this one. Let's try this problem. So I added a little bit something different in the 2x minus 1, but try it, see if you can do it, and then see what you get, and we'll do it together. And then find your domain. Okay, so let's solve this. Welcome back. Let me write it here. So the first thing we had to figure out, okay, was there any exponents at the front? No, so we don't have to solve for that. So the power rule isn't needed. But we did have minus, so that means we have to use the QR rule. So that means we divide. You combine the logarithms. So this is our A, this is our B. Okay, then we use the 1 to 1 to cross out our logarithms. Then what we do is we use our LCD. Then we distribute. Now I can combine like terms. Make sure all my signs are correct. Yes, we move the 2x becomes negative, move the 12 over, it's negative. So that means we have minus 1 minus 12. It's negative 13. And then we get 4 minus 2 is 2x. Divide the 2 out. And we should get x equals negative 13 over 2. And now we need to see, okay, what is our domain, right? So what we do is I take what is in my A and B, and those are what I'm going to use. So which one is closer to our answer? Minus 1 is greater than 0. And x plus 3 is greater than b, and those are what I'm going to use for the domain. So it means I'm going to do 2x minus 1 is greater than 0, and x plus 3 is greater than 0. And then we can rewrite that as 2x is greater than 1, which then we can rewrite further as x is greater than 1/2, because all I did was divide the 2 here to move it to the other side. And then the 3x greater than 0 will be x is then greater than minus 3. So let's see, what is our domain? So if I do negative 13 over 32, or 13 over 2, I get negative, and if I evaluate it into a decimal form, it becomes negative 6.5. So which one is closer to our answer? Well, so the domain for this one can be a little bit confusing, so we have to kind of evaluate it. So the domain x is greater than 1/2 is what the domain is for this, because it's more defined than that of the x greater than minus 3, which is not as restrictive. So the 1/2 is when I'd want to take priority in this case. And if we look at our answer, the negative 13 over 2, which is evaluated to negative 6.5, it actually is outside of the domain. So in this case, the answer is technically not valid because it does not satisfy the requirement for the logarithmic expression. So the one that is technically more restrictive is going to be the 1/2. So this is why our domain for this one has to be the 1/2. But most of your problems will be similar to what we did in the last one, where the domain is a lot clearer. But since our value at the end was negative 13 over 2, it makes it a little bit more difficult to figure out what the domain is. Okay, so let's do one closer to your classwork and closer to what you'll have if you were given an exam question. And let's do this problem. So if you can, try evaluating this on your own. So log of 6, so x plus 6 minus log of 6x equals log of 6 over 36, or log base 6 is 6. So try this problem, and then we'll do it together. Okay, so welcome back. Let me rewrite this. Log base 6. Okay, so no powers. We just evaluate by looking at our rules. We have the QR rule. Combine the logs. And then we use our one-to-one property across all our logs. So you notice this is just becoming the same pattern over and over and over. I think the evaluation is the easy part. It's just figuring out the domain is the harder part. Okay, then I multiply the LCD. Get rid of that. Okay, combine the x, move the x over there. So now it's going to be 6 equals 35. X divide the 35. So x equals 6 over 35. So we can't simplify this even any more than this. Now we need to figure out what is our domain. So I look at, okay, my x plus 6 and my x. Well, if I don't have any value next to my x, that means we have to think of it as x is greater than 0. And then for this one, I move the 6 over, so then x is greater than minus 6. So let's see. Our answer, 6 over 35. 6 over 35 evaluates to what? To about 0.17. Not 0. Not negative. So I would say that's actually closer to 0 than it is to minus 6. So that means our domain is going to be this. So that means 0 is more restrictive than that of x is greater than minus 6. So I could also write this as domain, or df is 0 to infinity. So this is section 5.5, solving logarithmic equations, part 2, type 2.